Good morning to all. Today we are going to start the cellular architecture in wireless communication. So in this unit we are going to see about the various types of multiple access techniques which is used for wireless communication along with the capacity calculation, cellular concept, how the frequency reuse has been used in wireless and mobile communication, and what are the types of channel assignments, handoff, interferences and system capacity, trunking and grade of service along with the capacity improvement. So let us see the fundamentals of multiple access technique that is used in wireless communication. So we know that the wireless communication, it is due to the electromagnetic radio wave propagation through the free space or air. So day by day the mobile user has been increased. So but the limited spectrum we have as a standard that is given by the IEEE. So within the limited frequency spectrum, how we can able to assign or how we can able to accommodate the more number of multiple user. So there comes the technique which is called as multiple access technique for wireless communication. So here it is mentioned as four different wireless multiple access technique, that is frequency division multiple access technique, time domain division multiple access technique, spatial division multiple access techniques, and pattern division multiple access technique. So these are all the figures which explains the difference between the different types of multiple access technique. So what is multiple access techniques? So the limited frequency spectrum can be used by the multiple mobile users simultaneously. That is the concept of multiple access. So from the name itself we can able to understand that. So the single available resource can be utilized in a multiple way, that is a multiple access. So the multiple user can able to access the limited resources, that is a meaning for multiple access technique. So among this four multiple access technique, here SDMA, TDMA and PDMA are orthogonal multiple access techniques, whereas the pattern division multiple access, it is related to the non-orthogonal multiple access techniques. Here this is a diagram which explains the difference between the orthogonal and non-orthogonal multiple access techniques. Orthogonal multiple access techniques means each and every user has been in a difference, that is there is no correlation between the different kind of user, whereas in orthogonal non-orthogonal there is a correlation exists between the number of different users. So here this is the diagram which explains about the pattern division multiple access technique by using the orthogonal frequency division multiple access technique, which is which here the difference between the Tdma and non-orthogonal multiple access techniques. Then here we have introduced the what is the multiple access technique. It is used for many users at the same time, and it is used to share the amount of finite amount of radio spectrum to give high performance. So here since it involves multiple users to access at a time, duplexing is generally required. It can be used for frequency and time domain. So what does the meaning of frequency division multiplexing? So here frequency division duplexing, it needs two different frequency bands for each and every user for its forward and reverse channel. So here since it uses a two different frequency channel, the duplexer is needed. Frequency separation between the forward one and reverse band is always constant. This is nothing but the FDD. Whereas in TDD, time domain duplexing, it uses time for forward and reverse link. Whereas in the FDD, we have used the frequency for forward and reverse as a difference. So the multiple users share a single radio channel. You know that is similar to the FDD. So as similar to the FDD, here we have two time slot, one is for forward and the another one is for reverse. So when compared to FDD, here there is no need for the duplexer in this TDD. This is a difference between this diagram which explains the difference between the forward and reverse channel in terms of time domain. And this is the classification of multiple access as we said already. So these multiple access can be categorized into two different systems, that is nothing but the narrowband system and wideband system. So this is the introduction of multiple access technique which along with FDD and TDD. So here as we said already, FDD it uses a two distinct band for forward and reverse channel, whereas in the TDD here the two different time slot is used for forward and reverse links. And this is a diagram for the FDD as well as the TDD. So here this is a frequency split, whereas in TDD it is nothing in terms of time split. And here the major means mostly used multiple access techniques in the orthogonal frequency division is FDMA, TDMA and CDMA, whereas now it is used for LTE band, it is used for NOMA, that is non-orthogonal multiple accessibility, which comes under PDMA, that is pattern division multiple access techniques. So here, as we said in the previous slide, narrowband system and wideband system, we have two category. And in that narrowband system, narrowband FDMA, the user is assigned with a particular channel which is not shared by the user, and the system is called as FDMA FDD. Similarly, for narrowband Tdma, the user allows to share the same channel but allocate at a different unique time slot to each user, and it can also be called as Tdma FDD and Tdma TDD. And here, these are all the narrowband systems. If it is narrowband, means large number of narrowband channels are used, usually in terms of FDD. So it can be of FDMA in combination with FDD, TDD, and also the TDMA in combination with FDD and TDD. And this is a pictorial representation for the classification of all these three. So first one is for frequency division multiplexes along with frequency division duplexing. So it shares the number of users in the vertical manner, right? So each and every user has two distinct band, and it is shared, that the frequency spectrum is shared in the vertical manner, FDMA, FDD. And FDMA, TDD, here all the user has two different time slot. So the two different time slot for each and every user has been shared in terms of horizontal, in a horizontal manner. You remember in that way. And this is a TDMA FDD. So similarly, the TDMA FDD, we have two different time slot for both, for each and every user, and the time slot has been divided in vertical manner for each and every user. And this is for TDMA TDD. And here TDMA TDD, each user has a two distinct time slot for forward and reverse channel that has been divided among the total spectrum in a vertical manner. And this is for wideband system. So similar to the narrowband, wideband is also have many combination along with FDMA, CDMA and TDMA, along with FDD and TDD. And this is the representation of CDMA FDD, that is code division multiple access with the frequency division duplexing. So here we have the different codes has been assigned for each and every user up from 1 to n, with two distinct channel that is shared in horizontal manner. And CDMA TDD, here the code is assigned in a horizontal manner, but it is in different time slot for both forward as well as the reverse channel. This is a sample cellular systems from the old days, which uses a multiple access techniques, right? Like AMPS, GSM, VSDC, DEC, and IS 9000, IS 995. And this is for here we have, up to this we have seen the introduction of the multiple access techniques. So in the next class we will see the frequency division multiple access separately and time domain multiplexes separately. Thank you.